Okay, so it's recording. And then this one. Okay, and then we can start the VM. All right, so I'll kind of give you like steps of what you would have to do, okay? Just kind of give you an idea. But like I said, we have now two techniques, symmetric and asymmetric encryption. You know how to use symmetric encryption, but that had a key. To exchange that key, we're going to use asymmetric encryption. It should be this one. So I'm going to log in. All right, so let's open up the terminal. Navigate to the desktop. Going to navigate to the class 350. And now I'm going to navigate to RSA, which is where our code lives. Okay, so RSA full code, right? So that's what we have. So basically, you want to achieve confidentiality, but now you also want to exchange the key securely. So create, file, plain.txt, right? And then just write something in there. This is a secret message, right? Something like that, right? So you can say October 19th, 2023. Okay, so that's basically the file. So you create that. Then you already know how to encrypt. So you would do something like, let's say, OpenSSL, AES, CBC. This is not the actual command, right? And then you would say -in plain.txt -out cipher.bin, correct? And then you need a key, right? So -k, it's uppercase, and then also the -iv. The IV you can just send in an email, it's okay, because they wouldn't be able to decrypt anyway if they don't have this one. So this is really the only thing that I would recommend that you exchange securely. Got it? Remember, again, this is not the exact command. You need to go back to your notes. I may be missing like the -e and all that. Now, this was the key, correct? For symmetric, and this should be ciphers. So you would take that message, encrypt it with some key. Let's say that the key is, you just pick a key. So it's like, a random set of numbers. Something like that. That's your key. Got it? But in the past, when we've done this exercise, you've done this already, you would just email this, right, to your friend. You would email them that. But that was in plain text. And so anyone that would intercept that would be able to break your cipher. So that's what this one piece of information is what you're going to encrypt using RSA, the other algorithm. Got it? So once you hit enter here, this would generate cipher bin, right? That's the message about October. You need to just send that message to your friend, like just email them that. Okay. Okay. And so you can send that message. So they have it over there. Obviously, they need to know that you use AES, that you use CBC, and they need to know the initialization vector. But those are all parameters that you can share in a plain email. No problem. Okay. Now the question is this one. So I'm just going to hit enter here. It's not going to work, but I want to record that number, right? Let's say that's the key. So now that key, we need to encrypt in some way, right? And so what you're going to do is you're going to use RSA to encrypt this, okay? Which means you will need to generate public and private keys. Each of you needs to have public and private keys, right? To be able to send those out. So now we're going to look at how we can go ahead and do this process, okay, of encrypting this and exchanging via email. All right, so let's go ahead and actually I'm going to copy that value because it's just a string. I'm going to do control copy here. Okay, and now let's go to the code, which would be RSA full, like that. Okay, so this is our RSA encryption algorithm. Okay, so the challenge is going to be basically how to send the cipher. So here in the past, I used plain message was Claude Shannon is the father of cryptography. But now the plain message will be that key. Okay. So this is what you're going to encrypt with RSA. Got it? All right. So you're going to generate a public and a private key, each of you. And then your partner also needs to generate a public key and a private key, and you have to decide which key is the one that you need to use. Got it? That's the trick. So you can, the public key is just going to be a number, so we can run this right now. Control X, Y. And we're going to do Python here. And so now this is your public key, this is your private key. All right, so we want to do encryption. All right, so let's say that Bob is this and wants to send a message to Alice, that key. What does Bob need to encrypt the message? We know it's a public and a private key, but which public and private key do they need? This is Bob. And Bob is sending to Alice and wants to achieve confidentiality. What does Bob need? Keep in mind, the private keys cannot be shared. Only the public keys can be shared. So if Bob uses his private key, then he can share the public key, right? But that doesn't achieve confidentiality, right? What does Bob need then? Her public key, right? So maybe then Alice needs to make available her public key, but as we have learned, that's achievable. So then what's needed is this needs to be shared by Alice, sent via email. That's okay. Totally okay. And then you and your code actually don't need to generate keys. In fact, right? Just use her keys. So you will use this to encrypt that code. You send that code, and then what does Alice do? Alice will decrypt that with her private key. Does that make sense, guys? Yep. All right. So I'll show you now so that's the thing that I say why it's so important to work with partners. Doing this now becomes a little bit tricky to understand but the nice thing about this is these are just numbers, right? So you can just plug them in. So now let's go ahead and let's encrypt that message in the code here. I will do it here in the computer, and then you just have to do it with your partner and do it correctly. All right, so we've got the functions already, right? So it should not be too bad. Okay, so let's go ahead, go into the nano editor. So I've generated the keys. And now we are going to add we have the plain text already. And now we're going to just create a cipher, which is going to be created by using encrypt. We have an encrypt function in this code already. This encrypt function takes in as input the message, which in our case is plain message, comma, and then what else? It should take the encrypt takes the E and the N, correct? So it should be E, comma, N, just like that. Now remember, here I'm generating the keys, but when you're working with a partner, actually, you generate the keys once, know what your numbers are. Then I would suggest comment out generating keys, and then think about which numbers you put in where, okay? So that's really the important thing. So now I have the cipher, and I'm going to print it, okay? So let's go ahead and try to do that. Okay, so I'm going to run it. And as you can see, it generates something like that. Okay, you can also do print hex list. Oops, sorry. In the code, we have a function. But there's several helper functions. They should be here, I think. Print hex list, there it is. Okay, print ciphertext in hex. Okay, so you can also, if you want to view it, you can do print hex list, and then you just provide cipher in there. Okay, so let's go ahead and run that. And it kind of looks like that, I guess. Okay, so we managed to encrypt the message. Okay, now let's decrypt it. So we're going to now say decrypted plain, and this is going to be decrypt. This will take cipher. So this takes cipher. And it takes D. Okay. Now here, the way this function works, and the functions kind of work like this. you actually provide P and Q, even though N is equal to P times Q, because you're decrypting, you would have these parameters, right? Because this is how you generated the information. So the file that contains D also has P and Q. So the function then, you can provide P, comma, Q. This is in your code anyway. Do you see what I'm saying? You'll generate the keys. You will share the public key only. When you get the message, you have P, Q, D, everything, and you can decrypt. Got it? So that's going to be in there. So you would want to save it. Okay. So keep in mind, for these numbers, I used a seed size of 16. I really just want you guys to play with these parameters, but keep it at 16, 32, okay, so that they don't get too big. Maybe 256 might be an optimal one, but they do start to get pretty big, okay? And so let's see if this works. So DP and Q, and then we need to print decrypted plain. So decrypted. Oh, print, sorry. Print decrypted plain. Okay, so now we're gonna run it. And was that the password? One, three, oh, sorry. I'm missing a parameter there. One, three, two, four. Ph.D. That's interesting. Okay. Let me try a bigger. I wonder if it's the 16 that's causing the problem. So let me try 256. Let me try the Claude Shannon thing. Let me try this one. Okay. For some reason, it's cutting out. Wait a minute. Comment out these two. Okay. Try it again. Okay, there it is. Yeah, so it's, I had from the homework, from the Tuesday problem in there. Get rid of those, right? And generate the P and Q. You know what I mean? So I hard coded these from last Tuesday. So just get rid of these, right? And instead, and so we're going to generate the prime numbers. I'm trying just Claude Shannon is the father of cryptography right now with the approach that I mentioned. So I'm going to go ahead and run it. And it does say Claude Shannon is the father of cryptography. Okay, now I'm going to try the password that I was talking about for symmetric encryption. So it should be this one over here, right? So 1324 ASD. 1324 ASD. All right, so we are getting, let's just double check that we are getting the correct. 1324 5636 7823 457.84 ASD. All right, so there it is. Got it? Does this make sense? So this just completes problem 3, right? Basically, problem 3, this is what you have to do. Kind of show, so you should show Claude Shannon is the father of cryptography. For problem 4, what do you have to do? Remember, I'll repeat. Maybe I'll just have the command here. There it is, OpenSSL, AES, CBC, plain, cipher. You're going to encrypt with this key. Shoot the cipher bin to your partner, okay? You can tell them, I use AES, CBC, I use OpenSSL, I use the IV, was this number, so on. But the key remains this, right? You can't send this via email, okay? Since you cannot send this via email, you're going to go into the RSA code. And this is for problem 4. And I have added that the key as the input. Yeah. You need to encrypt. So you really only need to use, actually, well, one person needs to encrypt, one person needs to decrypt on the other end. Okay. The trick is, what are the correct keys to use? Right. So each of you, because you're going to do it in 2 directions, right? So Bob sends to Alice, Alice sends to Bob a message. Put your name on it or something. So you should only run the gen RSA ones, right? And save the P and Q as well. So really you need to save D, P, and Q, and that should stay a secret. The only thing that can be shared, right? If you're Nathan, you can only exchange E and N, correct? And then that's it. And then once you encrypt the message here, you need to send this cipher to your friend. So you can just hard code this into email and copy paste it. Okay, so that you don't have to write it to a file. Although if you use pickle, what was it? Pickle dump, pickle load. I already showed you how that works, and that should do it too, correct? Do you want me to add that in? It wasn't so difficult. So it was pickle, right? Import pickle. Do you guys remember? So import pickle, right? And then where do I have this? I think I put this on the GitHub. Cryptography. I think it was in the CBC XOR 2, I want to say. Yeah. All right, so then you would need to write out so you're gonna do what? So this is not even byte array, I don't think. This is just a string, I want to say, but you can try. So this would be here, right? In cipher. Just write it out to a file with pickle. It's like a list, I think. So then we're gonna do file x equal open pickle cipher, pickle cipher, and then dash. I think this does not look like a byte array to me, so I'm just going to try W right now, but we might change it to WB. And then we're going to do pickle dump, pickle.dump, pickle. That's going to be the name of the the input. Sorry. So in this case, cipher, comma, file X, right? And then we just close file X. Dot close. Right? This is exactly what I did in the previous example. And now we would read it in. So we're going to do file Y equal open. This should be the name of the file. So pickle cipher. And then we're going to say, since I don't think it's a byte array, I'm just going to say read R. Okay. And single quote here. Okay. And then we're going to say from pickle cipher. And it's going to be pickle load, right? So pickle. And remember that the point of this is that you don't have to deal with formatting and stuff. Just a copy of what's in memory, basically. Pickle load. File Y. And then close file Y. And if file Y dot close. And if we're lucky, then here, where we do decrypt, now we would do from pickle cipher, right? Because it's the file it's what we just read from a file into the variable, and hopefully it'll give us the code. Let's try the Claude Shannon one first. Okay, so control X. So hopefully it'll work. Argument must be string, not bytes. Is that to be WB? Yeah, maybe it has to be WB. So let's do WB for both. So WB and RB. I guess if it's in RAM, it would be bytes, right? Okay, so let's do that. Okay, that's it. You guys understand? So this it makes it easier for you because what do you have to send now to your friend? You actually send them 2 files. If you feel comfortable doing it in one email, fine. I mean, however you feel comfortable doing this. But we have pickle cipher. Yes. Oh. There we go. All right, so if we do cat pickle cipher, we can't make it out, right? What's in there? It's encrypted, right? You should be convinced that that's what you send to your friend. What's in that file? What's in there was encrypted with RSA, right? It's the key. Or Claude Shannon, whichever one. So that's what you're going to send to your friend. We know then they'll receive it and load it. So the key is, which keys do you use? Right? That's basically it. So then I'm going to ls-l, plain is the message, and then the code. All right, so let's think the scenario. I'll use Bob and Alice. So again, let's do the message. Let's just for 100% ensuring that it's correct. There you go. That's the code 11324 ASD, right? And so that's the symmetric key. So you know how to do symmetric key between Bob and Alice. Now this key needs to be encrypted securely. So Bob needs to encrypt. So Bob needs to basically get an email from Alice with her public key. So really, for the encryption part, you don't need to generate keys, right? Or any of this. You do need the plain message. And then you just need this from Alice, public key, ENN. And then you can just go ahead and do encrypt plain message, ENN. Remember, this ENN came from Alice, right? Okay, that creates a cipher. Then use this code and send pickle cipher to Alice. Got it? Yeah, sure. And then Alice, on her end, what is she going to do? Alice generated the keys, right? Gen RSA. She sent the public key and she kept P and Q and D and N. She kept all of them. So print it. Like we do a print, actually. So when Alice did this, these are the parameters, right? So Alice's N is this one, D is this one, and P and Q are these, right? I think they're these two. Okay, right? So save those values. And then what is Alice going to do? She doesn't have to rerun Gen RSA, because if she does, she won't be able to decrypt. It's got to be the parameters that match the public key that she sent out. Okay, so then what does Alice need to do? She needs to save her parameters. And she will not use encrypt. She doesn't care about encrypting anymore. She will have to do this code here. Why? Because this code reads in the file she just got via email. So so pickle cipher, she's going to open it, pickle load, and then it's from pickle cipher. Then she's going to take that file and use decrypt with her D and her P and Q, and she should get the key. And then what does she do with that key? She uses it in OpenSSL to decrypt the cipher that she got. Any questions? Make sense? All right, so try it. You're only going to understand this once you try this out, and you have to work with a partner. So we've got about an hour, so I'll help you out. But this is, you got a trial and error, but you've got all the pieces here. Okay. Any questions? All right, I'll stop the recording and then just work with you guys on solving this one.